Okay, so now we want to look at the domain and range for the second sphere that we have sketched before, where we have a sphere with radius 2 and shifted at where the center is now at 300. Okay, so now we have to rewrite, you have to rewrite in terms to get the domain and the range. So we have to rewrite the original expression here in this form, where you have to modify it, you have to rearrange this and make the z just z is at the left hand side. Okay, then we have z square, so meaning that since from the original expression there is z square, so meaning that the possible z can be positive or negative, so that's why we have to put the positive and negative sign. So then now in order to get the domain, so this is the standard description of the domain. So domain is the set of xy are real, and then we have a square root function here, then all these should be positive and or equal to 0. Okay, so that is the constraint. So next, the range. So the range is all the values, the possible values of z. So from this expression, z can be positive and can be negative, so meaning that we can say z can be positive, z can be negative, and maybe z can be 0. But now you have to be careful with this standalone constant or just single constant here. So this form maybe becomes or will give z some interval, okay, some interval value of z. So now we have to investigate further. Okay, so this is the z, and it looks like we can simplify this. We can simplify this and then becomes 4 minus, so factorize, so x minus 3 square plus y square. That's it. Okay, so then we can see here all this value. Okay, even though there is x minus 3, but after that whatever value that we obtain here for any x that we substitute, the value here is always positive. So positive plus positive, and this always positive. So the value should be greater or equal to 0. So as same as before, we list down the smallest value in the bracket. So I put 0, 1, 3, and then 4, and then 5, and many more. Okay, so now we want to look the pattern of the value of z. If we have the bracket, the value in the bracket is 0, so your z is 4 minus 0, and we got plus minus 2. Okay, and we replace 1, so z is plus minus 4 minus 1, so we have plus minus square root 3. Okay, and then put 3 and put 4, so z is plus minus 4 minus 3, and we got plus minus 1. Okay, and when we put 4, so z is plus minus square root 4 minus 4, and we got 0. Okay, so you can see here can be 0, can be positive, can be negative. But now if we put 5 or greater than 4, so we have plus minus square root of minus 1, and the answer here is not exist. So if you increase the value inside the bracket here greater than 4, and you keep getting does not exist value, okay, for the larger value in the bracket greater than 4. So meaning that this is only the possible z that can we have, where z can be 0, positive, so the highest one is 2 and the smallest one is minus 2. Okay, so then we can put the constraint here of the range, so minus 2 to positive 2. Okay, so now this is our result. But then before we compare this with the sketching of the sphere, but we need to sketch the domain first. Okay, Now sketching of the domain. Sketching of domain. Okay, so we are using the constraint here where we have 4 minus x minus 3 square minus y square greater or equal to 0. Then we have x minus 3 square plus y square smaller than equal to 4. So now we need to know what is the graph. Okay, what is the graph of the domain. So let's ignore the inequality here. So we just have x minus 3 square plus y square equal to 4. So remember last time I already shared with you last week, I think, how to sketch the circle, and then you have to take note the center of the circle and the radius. So in this case we have a circle. This one is supposedly circle. Radius is 2 and the center is at 3, 0. Okay, so now we sketch the domain, the circle. So 3, 0. So 3, so 1, 2, 3, 3, 0. That is the center. And since the length is the radius is 2, so 1, 2, 1, 2, down here. Okay, so now we sketch the circle. Okay, so that is the circle. So now do we need to provide the dashed line or the solid line? Now we have the equal sign here, less than and equal to. So meaning that we should provide the solid line, and smaller than meaning that the shaded area should be lies inside the circle. So that is your region. Okay, so meaning that to make sure that your z values, they are always between -2 to 2. Okay, so this is only the value of x and y possible inside this circle. So now how can we relate the sketching of the domain, the range or the value of z, which is the range, and also the description of the domain with the graph that you already sketched on 3D. Okay, so now this is your domain. So you can see that your center is at 3, 0 on y-axis plane. So now you find out where is your domain. So what is domain? Domain is the region that you can see when you're standing on the z. Okay, and you're looking downward. Okay, so which one will be your region or domain? So it should be the circle in the orange color here, right? Where you can see that. So this is the value at x on x-axis, x. So this is 3. So 3, 0. X equal to 3 and y equal to 0 is the center, and these are all the measurements, so the intersection. So this one 5, we just compare 5 at x, and then 1 on x-axis, and +2 on y here, up here, and -2 on y down here. So meaning that what we can have here, this one, this circle is actually your domain. The region that you can see from the above is only this one or this one. So that is called region, which means that So this one is lying exactly on the floor. Okay, exactly on the floor. So meaning that x and y can be any numbers as long as inside the circle, but the value of z is always equal to 0. So that is called a domain. Okay, so now what is range? Okay, based on your observation about the range, which is the value of z, the value of z is, it is only possible, or it is only lying between -2 to 2. So then when you look at from the graph here, so where is your z? So this is your z. So the highest of z is located at 2, and the smallest of z is lying at -2. Okay, so now you can see, I hope that you can see the relationship between the graph in 3D and their range and also domain. Okay, so that is for the second sphere. Okay, so next we want to look at the third one, the third sphere, where we have C. So the equation is x minus 3 square. Okay, the similar size of sphere, but now the center is no longer on y and z0. We shifted somewhere. This way and this. Okay, so now we want to focus on finding the range and domain. Domain and range. So it looks like we have to rearrange this equation to be in the form of z is the function of x and y. Okay, so you need to rearrange this. Okay, so this is the new form of the given or the original expression. So in order for you to find the domain and range, you have to rewrite into this form. So you have to bring everything on the right side and just leave the z alone. So first you bring everything, all the terms. So this term and this term to the other side. So you have 4 minus x minus 3 squared minus y plus 2 squared. And then settle for the square first. Then meaning that you have to square root both sides. So this one, remember, because the original there is z minus 1 square. So when you only want to get z minus 1, you have to put the plus minus sign. Okay, and then we bring the minus 1 to the other side, then we have 1 plus minus of the square root. Okay, so that is the function now. Okay, now we are talking about the domain. Domain is the set of xy. xy are real. And then, okay, of course we have the constraint because the x and y, they are lying under the square root, so we just ignore the one because the one we fix. Okay, so the choice of you to choose the x and y depends on the value in the square root, alright? Because 1 is 1. Okay, so we want to make sure that the z always exists. So the dominant one is lying under the or below or under the square root. So meaning that the constraint is coming from 4 minus x minus 3 square minus y plus 2 square, and they are always positive. It can be 0 or can be 0. So that is the domain. And range, then is the set of the value of z. Z should be real. Okay, now we have 1 plus minus, and also we have 4 here. Definitely the z must be lying between the interval, some interval. Then we have to investigate what is exactly the interval of z. Okay, so now we look at for z. We have plus minus square root. Okay, 4 minus x minus 3 square minus y plus 2 square. Okay, so this one can be simplified to be I just focus because the one fixed, but then the value of z depends on this particular value for any x and y that you have chosen. Okay, so we have 4 minus, and I factorize. We can factorize x minus 3 square plus y plus 2 square. Okay, so this one always positive. So the possible value for that 0, 1, 3, 4, 5, and so on. Okay, now we want to investigate. So if the value in the bracket is 0, so your z becomes 1 plus minus square root 4 minus 0. So we can get 1 plus minus 2. So it's okay. So we just look at the final value later. So when the value in the bracket here is 1, so 1, so the z is 1 plus minus 4 minus 1. So we have 1 plus minus square root 3. Okay, and then 3, so z 1 plus minus square root 4 minus 3, so 1 plus 1. Okay, and then 4, so z 1 plus minus 4 minus 4, so we get 0, so 1 in 5, 1 plus minus 4 minus 5, which is greater than 4, so the answer here always does not exist. Okay, so based on our calculation for z, so this is only the possible z that we can have. So now we want to look at here. So so this one, choose different color. Okay, so this one will give you 1 plus 2, 3, minus 1. And this one will give you 1 plus square root 3, and then 1 minus square root 3. And this one will give you 2 and 0. And this is 1. Okay, so here, now what is the smallest value that we can have? It looks like based on this value, so we have so you have to sort into a number line. So you have 0, you have okay, let's say I put 1, 2, 3. Okay, 1, 2, 3, minus 1, minus 2, minus 2. So this is for the value of x, z, sorry, z. Okay, so now we have 0, we have 2, we also have 3, we have minus 1, 1 plus square root 3. So 1 plus square root 3 is 2.73, and 1 minus square root 3, 0.73. So we can see that the highest value of z is 3, and the smallest is so we have 1 minus 1, we have highest 3, and the smallest is 0, right? Okay, do we have negative value there? This one is supposed to be negative. Is it? 1 minus square root 3. 1 point something, right? So 1 minus, so this one is supposed to be negative. So we have negative there. And we also have when this is 1. Okay, so based on the list that we have here, where we got all the values based on the values in the bracket for any x and y value on the domain. So this is the possible value that you can obtain, and you can see that the highest of value of z is 3, and the smallest is a -1, and the rest they are lying in between. Okay, so here that is the smallest, and this one is the highest value of z. So we can see that z is lying between -1 to 3. Okay, so then we put that constraint, so z is between -1 to 3. Okay, so now it's time for us to compare the domain and the range. Before we look at the sphere, so now we want to sketch the domain. Okay, sketching of the domain basically based on the equation here. Okay, so now sketching of domain. Okay, so basically from 4 minus x minus 3 square minus y plus 2 square greater and or equal to 0. Then when we arrange, we have x minus 3 square plus y plus 2 square, which is smaller or equal to 4. Okay, so now we need to get the curve on the xy plane. So it looks like we have to consider the equation. Instead of we have inequality, we have to put the equal sign first. So what is this? So this is a circle, right? Circle equation radius 2, and the center is at 3 minus 2. So when you sketch that, so y x 3, so 1 2 3 4 5, so that is 3. So 1 2 3 1 2 3 4 5, y negative 2, so this is minus 2. So the point is here. So that is your center. And then radius 2, so radius 2 meaning that, so that is your intersect, that is your center. Now the intersect, so we got 5 and minus 1. So this negative 1, this is 5. It's 1, 2, minus 3, minus 4. 1, 3, 2, 3, 4. Okay, so that is your circle. Okay, so where is the shaded area on the origin of the domain? We have you have to sketch the solid line because we have equal sign here, and you have to shade the area inside the circle because we have the smaller than. So that is your region. Okay, now you compare whatever you have for the domain, range, and also the sketching of domain to your sketching of the 3D, which is your sphere, where the center is no longer is at 3 minus 2, and then z equal to z equal to 1. Okay, so this is from my previous sketching for this particular expression or two variable function. So this is the graph. So now this is your domain. As you can see there, this already been done when you do a tracing, right? So it is actually when you set the z is equal to 1. Okay, so how can you obtain the trace on y-axis plane? You set z is equal to 1, so you have this one. So you will get the similar graph. But this one, before this, it was about the tracing, and you have to combine them together and you will get that. So actually they are the same but in different terminology. So we call this as domain. So again, what is domain? Domain is your vision when you are standing somewhere here. Okay, that one is located at x equal to 3 along the z, and when you're looking downward and you can see this particular circle, or this one is actually your domain. Okay, where you can see from your sketching of domain, they have a similar graph. But this one, we are talking about domain. Domain is what is the possible value of x and y, so that all the value of z are real, right? So meaning that, where is your domain actually? So your domain is, okay, where is this one on the 3D? So the sketching is lying over here. That is your domain. So the possible x and y, so that your z is always real, is only lying inside this circle. But if you put outside, if you choose outside, and definitely your z does not exist because it is outside from the surface. Okay, you cannot see the surface over here, right? So without do some calculation, so from the graph you know that when you choose the point, let's say x equal to 3 and y is positive 1, for example, and we can see that definitely z does not exist because it is outside from the sphere or the surface. Okay, so that is domain. And how about range? So we obtain that the range that we just observed just now, so that the value of z is lying between -1 and 3. So now we check from the graph. So just focus on the z value here, or this one. That is the new z-axis where the x equal to 3, x equal to 3 is lying over. Okay, so the highest here is, so that is the value of z3. Okay, and the smallest z is, so it is a bit confusing, actually -1. Okay, -1 there for the value of z. So the 3 here is actually belongs to x, but the y is -1. Or you can see from your trace when there is z-axis. So the z-axis is here or here. So you can check from your trace. So your value here, that is 3, and the smallest value is -1. Similarly, you have z-axis here, so the highest value of z is 3, and the smallest is this one, where you already obtained in the finding the range. You have already calculated them. Okay, so now I hope that by now you can relate between the sketching of the whole graph in 3D and the domain and also their range. Okay.